All right. So hello and welcome everyone to MTRI's second August seminar series. My name is Luca and I'm a research technician here at the Mersey-Tobiatic Research Institute. I'm going to be your moderator for tonight. Now, before we begin, I would like to acknowledge that the MTRI is located in and we're meeting from Keswick, one of the 7 districts of Mi'kmaq, home of the Mi'kmaq people. We acknowledge the treaties of peace and friendship, and we thank the Mi'kmaq people for the generosity of sharing their homeland with us. Now, for everyone that may be joining us for the first time tonight and has not heard about the MTRI beforehand, I would like to give a little bit of background about us first. So the MTRI is a research-based nonprofit based in Southwest Nova Scotia, close to Kejimkujik National Park and National Historic Site, and located also within the Southwest Nova Biosphere Reserve. Our mission is to promote, sustain, and conserve biodiversity in Keswick and beyond. Now, with this, I would like to welcome tonight's speaker and introduce tonight's speaker, Dr. Ellen Whitman. Dr. Whitman is a forest fire research scientist at the Natural Resources Canada Canadian Forest Service in Alberta. And her seminar tonight will be covering wildfires in Canada, including some historic fire regimes, recent wildfire trends, and the natural role of wildfires in Canada. And yeah, it's really great to have you here, Ellen. And I believe that after this year of wildfires in Canada, I think many people, including myself, have been highly anticipating this seminar tonight. Now, before we begin, I would just like to remind everyone to keep your mics muted. We'll have a dedicated question period at the end of this talk. And if you have any questions that pop up in your mind during the talk, you can just type them into the chat right here on Zoom or on Facebook, and we'll read them out at the end to make sure that they all get answered. And you can also then ask your questions live during that dedicated question period. Now with this, I would like to hand over the presentation and the talk to you, Ellen. Thank you very much for coming tonight.
Yeah, thanks. Really happy to be here. Thank you, Luca. All right. So I'm going to start a little bit by talking about fire regimes in Canada, and specifically the role of fire in Canadian forests. Forests in Canada established somewhere between 21,000 and 7,000 years ago after the last glacial maximum. So we had that retreat of the ice sheet, and we sort of went through this period of almost like a steppe or prairie grassland type environment. And eventually we started seeing trees establish. And that we know from paleoecology, so methods like lake coring, for example, to look at things like charcoal or pollen samples of different tree species in the lake sediments, and also from dendrochronology, which is the study of tree rings, and something that can also be used to reconstruct fire histories. So using those paleoecology methods, we actually know that post-glacial forests burn quite frequently in Canada. So these forests really co-evolved with fire. It's been a part of these ecosystems for a very long time. What we see in sort of those lake sediments where we have pollen from different tree species and charcoal is an interaction between fuels, by which I mean vegetation or tree species, and climate, so the warmth or moisture, both affecting the level of fire activity together. So, for example, there's some evidence that we went through periods of low fire activity, a cool environment, a lot of conifer flammable fuels accumulated, and then when things returned to a warmer condition, we sort of had this combination of warm weather and fuel working together to create a fire-prone period, and we would go sort of back and forth through these cycles. But together, fire and forests have been on this landscape interacting for a long time. At present, about 1/3 of Canada's landmass is forested, and of that forested land, 75% or 270 million hectares is boreal forest. This talk will focus a fair bit on the boreal. I'm trying to keep it Canada-wide and to add some emphasis on Nova Scotia too. But what's shown on the map here is the extent of the boreal forest in green, and then all of those black areas are mapped historical fire perimeters from around 1950 onwards. So hopefully it's apparent to you all that part of the reason that we tend to think so much about the boreal forest when we talk about fire in Canada is because the vast majority of the fire that we have in this region is really focused in the boreal, and they're very closely connected. You can kind of point out maybe an interesting exception if you look at more southern British Columbia. There's a bit of boreal in the north, but there's also a lot of those black fire perimeter maps in the white area in BC. And that's because we have a different forest type there, but we still have very warm and dry conditions. So we've got lots of fuel and also the weather. But then we can kind of compare that to Eastern Canada, and you can see here are fire perimeters. They are there, even if you can't see them. They tend to just be quite small in this region. And that's sort of a function of the maritime influence from the cooler and wetter air that we have in this region. And then also the prevalence of broadleaf or hardwood tree species that we have here, sort of reducing the fire risk. I mentioned fire regimes earlier, but what makes up a fire regime? It's a way to describe the typical characteristics of fire for a specific region. Generally, we focus on things like the average fire size, the historical fire frequency. So by that, I mean, are you having a fire every 5 years, every 50 years, every 500 years? So that return interval for fire. The causes, we can break sort of fire into lightning caused or natural ignitions and human ignitions. And then also the seasonality. So some regions are dominated by spring fires. Others may have more of a summer fire regime, or in some places, like for example, California, you might have fire all through the entire season. So those are kind of the main features of a fire regime. I've thrown in a few bonuses there that we also might talk about a little bit. So these can be things like fire type, people will say, which would be surface fires, which are spreading sort of low down at the surface. Crown fire. So when a fire is all the way up into a tree canopy with flame lengths often above the canopy height, or maybe a ground fire, which is where fire is burning in sort of deep organic soils. And we also can talk a little bit about fire severity, which is really essentially the ecological impacts of fire. So are most of the trees killed? How is vegetation coming back afterwards? So all those things together are ways that we can characterize differences in fire regimes. And we'll talk a little bit more about that later on. But the key thing that you need for fire is sort of three things that we talk about. So you always need fuels. It's a little bit of a jargony term, and it's really prevalent in the fire community, so sorry if I use it a lot. But by that, I basically just mean vegetation or biomass available to burn. You need weather that allows those fuels to burn. So you might think of maybe like the rainforest, where there's lots of fuel, but maybe not ideal weather. And then you also need ignitions. And in Canada, we are not necessarily particularly ignition limited. There's lightning and there's people on a lot of the landscape. So we're going to talk a little bit about fuel limited versus weather limited systems. When I talk about a fuel limited system for fire, the image on the left is showing essentially a ponderosa pine, sort of shrubland, grassland, rangeland environment. And here it's more of a fuel limited condition. There's wide spacing between the trees. And in some of these fuel limited systems, for example, in the Southwest, you might actually need a wet year to make there be a lot more understory fuel like grasses in order to create that connectivity between the trees to allow fires to spread. Whereas in a weather limited system, which is much more so common in Canada and particularly in the boreal, which I've represented here with a photo of some black spruce, obviously there's abundant fuel, but if the weather isn't there in the right condition, we can't really enable that fuel to burn. So the fuel is always on, but we have this switch of weather where we need sort of hot, dry, or windy conditions that enable that fuel to burn. And generally speaking, a lot of our fire systems in Canada are more weather limited than anything else, although there are some fuel limited systems more in southern BC. So you're hopefully somewhat familiar with programs like Check Before You Burn, or maybe you've seen one of these sliding fire danger signs before that go from low to extreme. And all of these systems here are representing fire weather. So the assumption is that there's always the possibility of fuel, there's always the possibility of ignitions, but they're telling you something about how extreme the fire weather may be and what the fire danger is as a result of the weather. The reason that we put so much emphasis on fire weather is because it's really important to how much burns every year. So I've got an example on the left from the Western United States. All those green areas there are the forested areas that were studied. And what's being shown is the relationship between fuel aridity, so how dry and flammable the fuel is, and the total area burned in the forest. The two colors there are just indicating an earlier period and a later period to indicate that the later period had more dry conditions, but you can see there's a very strong relationship between how dry the fuel is in a given year and how much area gets burned. And then similarly, we find similar relationships in Canada. This is an example from a study that I did in Alberta. And in this case, blue is sort of telling you that something has a negative or a decreasing effect on the fire variables on the right. And then the red lines are showing that something has a positive effect. And here we found that total precipitation, so the rain input, strongly negatively affected the number of large fires, the total area burned, and the 90th percentile, or the extreme fire size. And then summer vapor pressure deficit, or VPD, which is another measure of fuel aridity that's particularly driven by temperature, has a very positive effect on the total area burned and the 90th percentile fire size. So fire weather in Canada is super important to what type of fire year we end up with. Circling back to those different fire regimes, we often kind of break different fire regimes into sort of groups. So one way that we might describe the boreal is sort of a low frequency, high severity fire regime. By that, I mean, we might have fires every 50 to 1,000 years, so low frequency. And when they happen, they are high severity. So they tend to be lethal to most of the trees, and we end up with quite severe tree mortality. But because of that really long-standing relationship that these trees and these tree species have with fire, they are very well adapted to respond to that. I've got a couple photos here to sort of give an example. On the far left, there is an aspen stand that, as you can see, was completely killed by fire, but there's been this pulse of regeneration of these suckering or resprouting clonally grown aspens that are coming back directly below those dead aspen trees. And this is sort of an example of self-replacement, and that's really common in the boreal. We don't necessarily expect there to be a succession through a whole bunch of different stages, but these adaptations allow trees to replace themselves with a new cohort of extremely similar composition, density, structure, that kind of thing. And there are also examples of this in our conifer tree species as well. So in that second photo, there's an example of cones from a jack pine, and jack pine are actually serotinous, so they hold their cones very tightly closed with a lot of pitch, and they need heat to open them. And once that heat from a fire or from very bright sunlight happens, they can release seeds and create those seedlings in the foreground, which are jack pine seedlings. So again, it's another mechanism to go through this resilient response where you get self-replacement of the forest. We also have sort of different responses in different ecosystems. So if we talk about like the montane, or maybe in some parts of southern BC, rather than having a resilient response where something is killed and then replaced, we also have examples of resistance to fire in our tree species. So this photo is of a Douglas fir, and it's a little hard to see, but there's charcoal there at the base. It survived a fire that actually like burned the soil all the way through. So there's now like a hole with some light in the background. But because this tree species has very thick bark, if it's a low intensity fire, which is what we would expect in a high frequency, low severity fire regime, then we can actually see these trees surviving through that resistance. So focusing in a little bit on the Acadian forest, I just want to sort of caveat over all of this. I feel like Nova Scotia is unfortunately a little bit understudied from a fire perspective. So I've done my best, but if people have thoughts or information, I'm happy to learn more. Historical records suggest that fires were actually quite common in Nova Scotia in the colonial period. Depending on the vegetation type, something like between 1 and 0.6% of the forested area was burning annually, kind of around like 1912. And fires were happening, though, every like 1,000 to 2,000 years, apparently. So we end up with, again, kind of another low frequency and then high severity or highly lethal to trees fire regime. And then when we look at how forests are coming back after that, not quite the same story as those two examples that I gave earlier. With an example from Maine in an Acadian forest there, they found that burned areas were sort of following a succession of different tree species over time. So going from colonizing hardwoods like aspen or birch for maybe like up to 70 years after fire, and then moving from there to a sort of combination of northern hardwoods like maple and like a mix of red spruce, maybe for about 150 years after fire, and then finally becoming more of like a typical mature Acadian forest with a mix of northern hardwoods and spruce and fir, something like 100 to 200 years post-fire. So following that successional trajectory is a little bit different than what we talked about with that self-replacement in the boreal. To look at some other aspects of fire regimes in Canada, this is the same map, but now I've colored the fire perimeters by the cause of the fire. So in black, we've got lightning ignited fires. In that orange or red color, those are human caused fires. And in the yellow color, those are sort of unknown, undetermined, unreported fires. And hopefully it's apparent that the majority of our area burned in Canada comes from lightning-caused fires. The reason behind that is mostly just that they're quite remote. We don't necessarily know when they started. They may be a long time to respond to if they're far from a fire base. People don't notice right away, whereas human-caused fires tend to be near people. So they aren't necessarily responsible for the majority of ignitions, or slim majority perhaps, but they are responsible for the majority of the area burned. But Nova Scotia is actually kind of a bit of a different case here again. In this region, we've got very much a human-dominated fire regime in terms of cause, and that's also reflected in the seasonality of those fires. So it's quite typical for human-caused fires to be more likely in the spring, and that's also true in this province where the peak of the fire activity tends to be around May, and that's also been historically true in some old reports from like the 70s that I found as well. Whereas in our lightning-dominated areas, we tend to experience fire much more so into the late summer. So a bit of a difference here, but it's actually been sort of consistent with what we've observed in this province in the past. And yes, here's that figure from 1979, where they showed that lightning fires were about 1% of ignitions for that period from 1926 to 75. I want to touch briefly on Indigenous cultural burning. The difference here between like a human-caused fire versus a cultural burn is that these are done for a purpose. So for example, to open up forests and create habitat for wildlife or for hunting, to make travel easier, to promote the growth of certain plants or materials for foods or medicine. And often these were very low intensity fires, and they were applied to the land in times and places that it was felt safe and appropriate to do so. So something that we've often heard about in the West, this is an image of a prairie crocus, and we've sort of heard that, once the prairie crocuses are out, that was a sign that it was time to burn the land again, and that spring had come and that the weather was right for burning. When we have these really low intensity, so like not very hot fires, trees can actually survive those quite well. They create injuries on the trees, which are called fire scars, but it doesn't actually kill the whole tree, and it can sort of attempt to close those in. And as it attempts to do so, we end up with a record of the fire history. So to give you an idea of what that looks like, if you're to take a section from a fire-scarred tree, that's what's shown on the right, and all the little fire scars there are pointed out. And when earlier, I really emphasized the importance of weather to our fire regimes, but when we have these historical fire scars, we can actually sort of compare how that tree or how that fire regime rather was responding to weather versus to human indicators. These are some results from a study from Dr. Kira Hoffman, and in this work, it was done on Hecate Island on the Central Coast in BC. And here they found a much stronger relationship between human drivers of fire than weather or climate. So as you can see, there's a clear relationship between the distance from the habitation site of the First Nations people in terms of the frequency of fire and the number of fire-scarred trees. And they also found that 36% of those events occurred in warm and dry years, and only 50% were occurring in average years, and then 14% in cool and wet years. So the majority of the burning is actually happening not under extreme conditions. And so that decoupling between the climate and the fire regime here is the responsibility of people in that region. I kind of struggled to find a lot about cultural burning in Atlantic Canada. Early colonial descriptions of the forest refer to it being park-like or open, which is something that we often attribute to fire, which would have been being used by First Nations. But other people have said that those descriptions maybe were more like propaganda to try to convince more people to immigrate into this beautiful park-like forest. But there is evidence of human use of fire, mostly in pine areas or conifers rather than in hardwoods. And it was more prevalent in sort of the southeast, so more almost like south of New York in the United States, and less prevalent closer to Canada and Nova Scotia. Early records from settler colonists don't really mention cultural burning or agriculture being practiced in this region. And to me, it's unclear if that's simply because they didn't really know what they were seeing. So they may not have recognized that the landscape looked the way it was because of the influence of people on it, or possibly, there's abundant resources with oceans and lakes that meant that this type of practice wasn't necessarily important here. Personally, I wouldn't rule it out, and it's something that we would need to learn through traditional knowledge and dendrochronology to really get a better understanding of how that fit into the fire regimes in this region. So with that background, let's talk about sort of what's been going on in Canada recently. I'm going to start with the number of fires. This is a plot showing the number of fires annually in Canada for the entire country from 1959 to 2015. And I hope it's apparent there's not really much of a trend there. Maybe a slight decline, but it's not a significant one. It's not meaningful. But that lower line there that's dashed shows a significant increase in the number of large fires. And this lack of change in the number of fires is something that I've heard sort of emphasized sometimes in like the media or in politics as an indicator of like that we're not really experiencing any change in fire and we don't need to be worried. We'll circle back to that. But when we look at it regionally, it's actually a little bit different. So the thing with fire is that it's highly regional, it's highly dependent on weather and local fuels, and we actually see quite different trends when you break things down and don't look at them cumulatively. So the map on the right is showing areas in yellow that have had an increase in the number of fires, areas in blue that have had a decrease, and then those diagonal lines indicate if that trend is significant. So there's been a very minor significant increase in the number of fires in the Yukon and Northwest Territories, Northern Saskatchewan, and also a minor decrease in the number of fires in sort of Eastern Canada in the south. But when we look at area burned instead of the number of fires, there is a quite significant increase over time that's been happening since the 1960s. So this is apparent at the national level, but once again, what's driving that is actually very regional. So if you're thinking to yourself, well, like my cottage in Quebec hasn't had any changes ever, and that's not what I've experienced. Maybe that's because this is mostly being driven by the West. So the place we see these big changes is really in the boreal forest, particularly in the West, and to a lesser extent in Northern Quebec as well. And then there's also some declines and decreases that have been happening. However, none of those decreases are significant. So we actually can say that area burned by wildfires has been significantly increasing in Canada. I wanted to break this down for you folks sort of specific to Nova Scotia if possible. So I took some of the provincial fire data from I think 1985 onwards. And there has actually been a significant decline in the number of fires in the province, similar to that regional decline that was happening in the Southeast. And again, similarly, there hasn't actually really been a change in the area burned in this region. Right now, the data is sort of available up to 2021, but if you add 2022 and 2023, there's kind of this insane spike relative to the recent history. But even with that really dramatic shift, it doesn't actually make it a significant trend because it's just a single point on what was essentially a flat line. So let's talk a little bit more about 2023 and sort of what's going on there. So when we look at area burned, nationally, the area burned this year is at currently 13.4 million hectares, which is about 7 times more than the normal average for the past 25 years. So it is very much a meaningful and severe year in terms of area burned. And in Nova Scotia, it's actually sort of even more pronounced. It's almost, I believe, like 30 times the normal relative to the past 25 years. But the thing with those past 25 years is like, that's where we have really good data that we're confident in and data sets that go back consistently to that time. But again, that same report from the 70s that was looking at data back to like 1915 also includes some information about annual area burned that I thought folks might be interested in. So in recent history, with that declining number of fires and the small fires that have been happening, the average annual area burned is about 773 hectares. But in 1918, 30, 34, 44, and 47, there were over 15,000 hectares burned in Nova Scotia, which is less than this current year, which is the 24,000 hectares. However, in 1920 and 21, according to that report, over 30,000 hectares burned in those years. So this may not be like unprecedented for Nova Scotia. It doesn't mean that it's not a significant event or a significant year, but I think it's worth like putting it into context that to some extent, this area burned is not something that these forests may have never experienced. Circling back to that, well, the number of fires isn't changing thing. We can look at the national average number of fires versus this year and the same provincially. And in both cases, it's a bit of a high year in terms of the number of fires, but the sort of scale of difference of the area burned is much more pronounced, and I would say both ecologically and in terms of impacts on people, much more important. So finally, we're going to talk a little bit about the drivers and outcomes of fire regime change. So I'm going to start with this. Are we sure it's climate change? Are we sure climate change is the cause? This is a question that I get a lot in interviews and so on. And I don't want to be too facetious or jokey or dismissive, but we are very sure that climate change is the major driver of that long-term trend in increasing fire activity. So as a reminder, we already talked about how important fuel aridity is to area burned. And what drives fuel aridity is the combination of moisture, so things like precipitation and relative humidity, but temperature is extremely important to fuel aridity. And when we look at trends in our weather over time, we do see that there's been significant increases. This is a map of North America with trends of vapor pressure deficit extremes from 1979 to 2020. Everything with sort of a warm color has been increasingly arid, so warmer and drier over time, and anything in blue has declined a little bit. And you can see there's a really pronounced trend in the Southwest, but also, places like Nova Scotia have also been experiencing increased aridity. So what's behind that? You might think, okay, well, we are also experiencing changes to our rain with climate change, so maybe that could compensate. But we know from other research that for every 1 degree of warming, precipitation needs to increase by 5 to 15% in order to compensate for the drying caused by warmer temperatures. And the really key thing here is that warm air is able to pull more moisture out of fuels. So even if you get more rain, if it's warmed, for example, 1 degree, you may need a lot more rain in order to compensate for how much moisture is being pulled out of the vegetation. So I decided to do a little focus in on Nova Scotia here too. This is just for sort of the center of HRM. I couldn't do the whole province on short notice, sorry. But when we look at the average maximum temperature, there has been a significant increase over time. It sort of looks like it starts maybe in the 70s or 80s there. But in this region, there's been about 1.3 degrees of warming thus far in the maximum temperature. And then at the same time, there's no trend in the total precipitation that was experienced. So we aren't necessarily getting that increased input in rain or snow that we would need in order to offset the warming. So that's sort of your background on why climate change is really important to fire, but there are other things that matter too. So we're going to discuss those as well. And one of those is fuel buildup. And this is something that I think is much more important to emphasize in those high frequency, low intensity or low severity fire regimes, like in the mountains or in BC, for example, where we had a lot of frequent historical human fire. And then with the advent of sort of colonization and modern fire suppression, we get sort of right around the time of World War I. In this particular sample, we suddenly see no more fire happening. And so those little fire scars stop forming and we get a big gap. And those pauses in frequent historical fire start allowing fuel to build up, which does increase fire risk. And this is also seen when we look at the area around communities where we engage in a lot of fire suppression. This is a map showing essentially the difference between the relative recently burned area around a community, and that's in comparison to the surrounding area of the ecosystem, showing that a lot of these communities have way less burned area around them than the natural areas outside of them, which in some ways is a good thing because we're being efficient in firefighting and keeping people safe. But on the other hand, it also indicates that there's a lot of fuel around those areas that maybe increase the risk. I mentioned burn severity earlier, which is sort of the ecological impacts of fire or the degree of fire-induced change to vegetation and soils. And this is where we're starting to see some of the changes in how those ecosystems are responding to this disturbance. This was a surprise to me, but we did find a significant increase in fire severity, as shown on the figure on the left, in northern Alberta in mixed wood, so forests that had both conifers and broadleafs, and then also open conifer forests. And the reason that might matter is that as you increase fire severity, you tend to lose seed viability of the trees. So the regeneration that happens afterward can be different. So changes to your forest that's coming back. And another thing that sort of influences that change is short interval reburns. I mentioned sort of frequent and infrequent fire regimes, and in that boreal forest, to have that self-replacement, those young trees that establish shortly after a fire need some time to grow and to have mature seeds, and to have those seeds a decent way away from the ground, and to have those seeds enclosed in pitch or cones in order to be able to produce a second generation if it were to burn again. But if things are burned very frequently, we can kind of miss that window, and that causes changes. And so we have found that there's been an increase in short interval reburning in parts of Canada. This is from Northern Alberta again. And what that leads to is specifically changes in the forest that comes back. So in the panel that's labeled A, we found that at our short interval sites, there were significantly fewer conifers than at our long interval sites. No change to broadleafs, but overall that translates into a more open, low density forest with a very low proportion of conifers. So you sort of start seeing a shift away from that resilient response to fire, and it changed to a more altered forest type. So how is this playing out nationally? If we focus in on one tree species, which is black spruce, which is found in, I believe, every province and territory, so it's a great one to pick on. It's actually quite fire adapted. It tends to come back very well after fire. But increasingly, research is showing that it's no longer having that resilient response, and instead it's getting either replaced by other tree species or not coming back at all due to severe burning and shortening fire intervals. And so as we kind of move from west to east, in the west, we're seeing regeneration failure or replacement of those conifer black spruce seedlings with tree species like aspen or birch. And then as we start moving more to the east, into the plains and shield, we start seeing it actually being replaced with jack pine, which is a conifer that responds very well to fire. So all of that is translating to changes in our forests after fire. This was supposed to be a talk about ecology, but I do want to talk a little bit about the human impact. As we've experienced more and more area burned, we're experiencing more evacuations and an increasing number of evacuees. And then on the map here, everything with a black dot is an evacuation, and everything with yellow was a fire burned area. And hopefully it's kind of apparent that where evacuations happen is not necessarily where the most fire happens. So this is an example where Atlantic Canada and Nova Scotia, in like kind of an unfortunate way, punch above their weight relative to the amount of fire that's happening there. And this is because of wildland urban interface. So people living in areas where they're very close to natural areas, close to flammable fuels, and really at risk from fire and from evacuations. Because of the legacy of development in this region and the concentration of people on the landscape, it is an area that tends to experience sort of more evacuation than you might expect, despite the less active fire regime. So that's everything I wanted to cover with the time I had. Thank you very much for the opportunity. I'm always like honored and excited to speak to Nova Scotians or about Nova Scotia. And yeah, thank you so much.
That was great. Thank you so much, Ellen. I really enjoyed that. Yeah, and it is kind of scary too, to see some of the things that you showed on the map there. Yeah, so again, thank you very much. I really enjoyed it. And we'll now move on to the question period. So anyone that has any questions, you can now feel free to ask them live right now here on Zoom or on Facebook. And Chad and I will also be reading the questions from the chat. So go ahead and ask your questions. And to break the ice, I will ask my first question because I have one. So you were mentioning that the East, or Nova Scotia, or the East of Canada generally, is sort of an understudied area for forest fire research. Do you know if, with the really recent changes, it seems like it's not that different from what it used to be, but the 2 last years have been pretty significant. Is there a push towards more research into forest fires in the East? Do you know of that?
I can't really speak for academia specifically, but I think people are quite interested. And I do know that at the Forest Service, we recently hired a couple additional researchers specifically in New Brunswick and Newfoundland. That the way we operate is we have service centers that serve large areas. So they're responsible for Eastern Canada. And so, yes, it is a concern. And I think like particularly that wildland urban interface aspect that I sort of ended on is a big reason for that. I think that the ecology is a big part of understanding the risk. So that's something that those people will address with their work as well. But yeah, I hope that this year has drawn a little more interest from others, but it was already trending that way. So I'm excited to see over the next few years if we do get a better understanding and like, I don't know, a larger area of coverage of research in that region. It would make me really happy.
Thank you. I think Jane has a question here. Jane, go ahead.
Hi, thanks so much. That was a really awesome presentation. There's so much information in there. You did a great job, Ellen. I was wondering how, when we're looking at Atlantic Canada, how it compares with like the northeastern states and in terms of fire regimes, because that's all part of the Acadian forest. And also, given that a lot of the fires in Atlantic Canada are human induced, how that's been impacted by colonialization and the changes in forest management over the years. And I know that's like a two-part and big question, but
yeah. So I'll start with the comparison to sort of forests in the eastern US. I think it's like decently similar in terms of a fire regime. My understanding is that lightning ignitions, like they obviously happen everywhere, and I think they're probably related in some ways. But I think they are also mostly experiencing a human-driven fire regime predominantly in those regions. And I think, again, the reasoning for that is, again, like that coastal influence, but also the prevalence of broadleaf trees. Something I didn't emphasize really is that when broadleaves don't have leaves, the fire risk is much higher. And that's part of why human-caused fires tend to peak in the spring. And so I would expect that to be quite similar. And then my understanding is like, you know, from a fire regime perspective, we often sort of lump forest types together. So if it's Acadian forest, I would expect it to be pretty similar. And then from sort of like a colonization perspective, I wouldn't necessarily expect that to have particularly influenced like the fact that it's a human-driven fire regime here, because I think it's like the dominance of the broadleaf trees and then the moister air that we have that makes it more human-driven in this region. However, there is something that I kind of ran out of time, so I had to cut some stuff, but I did want to talk a little bit about like the borealization of the Acadian forest, which is something that there's at least one review paper on that topic. And it's been suggested that through management practices around forestry or whatever, that we have favored conifers and softwoods because they are quite marketable. And that may have possibly increased the risk because we do know that boreal conifers are some of our most flammable high-risk species. So I haven't studied that specifically, and I wouldn't want to like claim that, you know, like industry has made things worse specifically, but I think that review felt that they confidently documented that shift in terms of how we may actually sort of, like you would think that climate would be pulling more on the hardwood side in this region, and yet there's also been a concurrent increase in conifers, and that's probably due to human management mostly. And then like speaking back historically, as I said, like I personally struggled to find a lot of documentation of Indigenous use of fire in Nova Scotia, but I think it's maybe more so a lack of documentation, publication, dissemination of traditional knowledge. So I wouldn't want to like say it's gone and it used to be super important, or conversely, it's still super important, everyone's doing it, because I just don't know.
There was a paper by Shalan Jodri that you might want to check out. She, if you haven't seen that one already, she did her master's on Indigenous use of fire on the landscape. So I can maybe share that with Chad and he can forward it to you, or Luca.
Yeah, I would love that. Thank you.
No problem. Thank you.
Okay, we have a question in the chat here. It's from Kate Goodale, and she's asking, I missed the beginning of you might have spoken to this, and do you see municipalities being proactive about fire protection, or is it more reactive?
Interesting question. Yeah, I think it varies a lot. There's some interesting social science around like how people learn from a really negative fire event. And it turns out it's like very complex in that some people learn that they are vulnerable and they need to do fuel mitigation and management, and they need to like change things, and they need to build multiple routes of egress, and they're like become extremely proactive from experiencing that. And other people learn that like life is uncontrollable and it's all beyond our power, and like there's nothing we could have done anyway. So like in terms of how people mentally respond, it's kind of all over the place. But then like when we look at it at a municipal level, I've found it to be quite mixed. Some places are very proactive. A lot of it is mostly based around sort of like thinning of high risk fuels. Kate, I'm sure, remembers the HRM commissioned a study about fire risk several years ago. But then like where it went is a little unclear to me. So I've had a few experiences where a region has gotten funding to like do a study or to adapt their policies or whatever to address fire risk. And then they sort of stall out once that's done. So I can't speak to what that municipality did with that study, but in other experiences that I've had, they kind of concluded like, I don't want to do that because it's expensive or whatever. But there are funding programs like Fire Smart in Canada. It varies a little bit province to province and in the territories as well. But in some places, Fire Smart will give communities money to do fire smarting or to like work on things. And in those cases, they've actually, I think, been pretty successful. Interestingly, maybe this isn't surprising because of the heavy fire load that they have, but the Northwest Territories communities are very proactive with Fire Smart, possibly like because of so many evacuations that they've had and the level of risk. And then in other cases, there's some situations where like NIMBYism plays a role. Like there's sort of a famous example of like obviously people don't really like the look of harvested or thinned landscapes, and like there's ways to do thinning of fuels that are more aesthetically pleasing. But like there's a kind of famous example in Alberta where a community was very opposed to the fire smarting because, you know, they love the beautiful nature and beautiful trees, and they didn't want that around their community. And so there's kind of a tension between the aesthetics that people want versus the risk that they face. So like it seems to be very piecemeal, since you're asking about like proactive versus reactive. In some cases, people have had bad experiences and then immediately responded and said, okay, like we need to change how we do things. And then in other cases, people have tried to advocate for change and then experienced very little. But I do think that funding through programs like Fire Smart is a massive help that allows communities to like actually like propose a project or do a study of risk that will target where future projects occur.
Okay, I think that sounded like a really good answer. I think Kate's probably satisfied with that. Chad, do you have anything on your Facebook side of things?
Yes, someone has asked how like global weather pattern changes and cycles impact North Americans' wildfire season. So for example, things like El Nino.
Yeah, great question. Fire is very fun to work on and really interesting in that it has a lot of teleconnections to other places. You're welcome, Kate. Yeah, I have a bit of a Western bias, so I wish I could say more about Eastern Canada in relation to this, but certainly like the main one that we're very familiar with is ENSO or El Nino, which very much does influence fire in Western Canada. So in places like British Columbia, Alberta, NWT as well, I think has a relationship with El Nino. And essentially those warmer waters in those actual El Nino years create less precipitation in Western Canada, which increases the likelihood of drought. And we often get like warm blocking ridges as well, which are super important for fire, where we have like a stable system that's very sunny and warm for a long time. And altogether, like what's happening in the oceans off of like the coast of, I don't know, South America or whatever, actually has like quite a strong influence on fire in Canada. And it does kind of mean that fire is cyclical in some ways. So sometimes people are sort of like, well, but last year there was no fire. Like 2019, I think was like exceptionally no fire, like almost the least that certainly in my lifetime that I've ever experienced, but like in some of our records, it was like off the charts low. And then people are very surprised when like it comes back again, and they kind of thought like, oh, fire was done or whatever. But because of these cyclical patterns or these things that like flip back and forth from El Nino to La Nina, for example, we do sort of see that there are cycles within fire, but then overlaid on top of that is that long-term trend in temperature and climate that's sort of continuing. Yes, so definitely teleconnections are important. There are other ones that people have identified. I think like the Pacific Decadal Oscillation is another one that has some connections to fire. But the main one that I feel like we directly experience very evidently is El Nino.
I personally have a question to kind of build off that. So we know with like El Nino and La Nina, that impacts our winters as well, and how much snow we get and how warm it is. So do you see like before fire season, if they have like a lot of snow and it's builds up over the whole winter, does that help reduce fires in the summer, or does it just melt in the spring, flood out, and then it's gone? And it's more like the more important factor is actually like the precipitation in the summer itself.
Yeah, no, winter snow actually does matter. One thing that's kind of interesting in fire as well, like I was talking about teleconnections, but we also have like multi-year patterns in fire. And so the drought the year before a fire season also affects the next fire season. So even if like that drought ends, it can have like a priming effect kind of, and that is often because of winter specifically. So if you enter winter in a drought and then you start spring in a drought again, kind of, and then it like fades away, it'll still possibly create this echo effect of a large fire year. And then in terms of like snow specifically, what kind of matters in particular, like obviously like big snow years introduce a lot of moisture, obviously, but what's kind of important is like the rate at which it melts. So if you have a big snow year, but then in your spring, it's like 20 degrees in May, all of a sudden in a matter of days, and it sort of runs off over the landscape, it doesn't necessarily get as much of a chance to sort of slowly infiltrate the way that it would, like if it just got to melt slowly in place over the span of like a less of a aggressive ramp up. And so when you get that runoff, you don't get as much recharge to like the soils and the organic layers, which can be important for reducing the fire risk. But then as the season progresses, when we really get our like drought driven fires, it tends to be more so in the later summer. And at that point, like your snow's kind of stopped playing a role, but I think it would certainly affect spring. And then also like if there's snow on the ground, like the way that we start up our fire weather indices is like, we don't even start them up if there's like X number of days with snow. So like the thicker the snow, if you have a heavy snow year, it's going to probably stay on the ground longer. So that's going to give you a shorter fire season. So it certainly does have effects.
Very interesting. Thank you. If no one else has any more questions, I have one more. So I work a lot on wetlands, and these ecosystems are, of course, wetter than typical forests. Do they have a like buffering effect against wildfires? Because I've noticed driving around the Barrington area, you'll see the wildfires like have gone through, and then they like meet a peatland and they stop, and there's no damage in that peatland, but the wildfire has gone around it. Is that something you typically see with wildfires?
Yeah, peatlands are super cool. I'm mostly going to have to speak from a Western perspective on this one, but like I think the function would be very similar in other places. So peatlands are kind of interesting in that they kind of operate a bit with that like on-off switch that we talked about earlier. So in like an average year or a normal year, peatlands are a barrier to fire spread, and they actually do strongly reduce like the fire likelihood or the distance that a fire might spread. They can serve as a barrier if the water table is high enough. But in drought years, depending on the type of peatland, they can actually conduct fire very readily. And so we can kind of break things into like fens and bogs. And then if fens are like, they have like a water table that's coming from other sources and they've got all these grasses or whatever, they may sort of dry down a little more slowly than a bog. And so often bogs will burn, but it has to be quite dry in order for that to happen. And actually very rarely, if there's enough trees, like a forested bog, it will kind of like independently carry the fire over the wet surface of the bog, which is kind of weird, but it can happen. But fens can also burn too, obviously. And in those cases, because of all the grasses, it's actually got quite a lot of fuel as well. So in drought years, they aren't so much of a barrier to spread, but in wet years they are. And we also find that they kind of have like a shadow effect in that they create fire refugia or unburned islands, often like on their lee side, for example. So an upland being near a wetland in some cases actually offers it some protection from burning, but it varies from year to year. So they aren't consistently a barrier to spread. So it's really important to be like tuned into like, what's your water table this year? Is it a drought year? How crunchy does this grass feel when I smush it in my hand?
Amazing. Thank you.
Ted, do you have another one? Oh, you're good. Okay, because I actually do have another one, but it's a really, really, really quick one. So again, Chad and I were doing some field work down in Barrington area, and we saw some of the fires and the damage that they had done. So we did notice a lot of trees. There was sort of a crown fire happening, so a lot of trees had lost their foliage. Is there any coming back for a tree that has lost its foliage during the height of summer, or are they a goner?
Interesting. Are you talking about broadleafs or conifers? Not sure that the answer matters.
This is as well as, I think we've seen both broadleaf and conifers.
Okay. Yeah. Generally speaking, like if it was involved in a full-on crown fire, like there is no coming back from that. So if it's like charred on the stem quite high up the tree, it is almost definitely going to die. If you see trees that have still like brown needles, so or brown leaves, like if they've been kind of like girdled rather than charred or torched, that they can survive, and that's kind of when you might get fire scars and coming back. So just because there's brown needles or brown leaves doesn't necessarily mean it's totally dead, but generally if a tree is going to survive, you would see some green vegetation on it. So if it's got like char all the way to the top, or if like there's no needles or vegetation left at all, I don't have high hopes for those ones.
Okay, I figured as much, but yeah, thank you. Okay, I don't have any more questions here. Chad, you said you didn't have any more over there on that end either. Okay, yeah, then with that, I would like to thank you again so much, Ellen. It was a really great talk, and yeah, I really, really enjoyed it. And also, again, thank you to everyone else that joined us tonight. And at this stage here, I'd also like to thank our sponsor for our seminar series, that's the Region of Queens, for supporting us in the seminar tonight. And for any future seminars, you can stay up to date with what's going to happen soon on Facebook, Instagram, all social media. And you can also watch tonight's seminar again if you've missed it. But for people that are listening right now, that probably doesn't apply because I have listened. Anyway, you can watch it again on YouTube or Facebook. And don't forget, we'll also be hosting more seminars throughout August. So we have 3 more coming up in August. Next week, we're going to be joined by Rebecca Mader from the Acadian University, and she'll be sharing her research on effects of hemlock woolly adelgid infestation and hemlock stands on the fungal communities within those stands. So very interesting. Next week, same time, from 7 to about 8 on Thursday. And again, you can join us here on Zoom or on Facebook Live. And with this, I would like to end today's session. Thank you so much again, Ellen. And I hope everyone stays well, and good night to everyone. So see you again soon. Bye-bye.